Hello everyone, this is Arjun and today we are going to talk about insertion sort. Insertion sort is simply a sorting algorithm that builds the final sorted array one at a time. This means that we choose an element at index I and then sort the subarray from 0 to I. Subarray means the part of an array from the beginning to the current element in the iteration. For example, if we have the array 2, 8, 3, 5 and 1 and suppose the current element is 5. So in this case the subarray is going to be 2, 8, 3 and 5, and if the current element would be 3 then the subarray would be 2, 8 and 3. A very common example for insertion sort is the card sorting algorithm. We will learn soon how it works. Insertion sort does have a few advantages, like its implementation is pretty easy. It is very efficient for sorting a small size of array. It is more efficient than the other sorting techniques like bubble sort or selection sort. And it is very fast for datasets which are almost sorted, meaning the elements are not very far away from their actual sorted positions. We can see this from the following example. Here we have the general sorting algorithms you know about. We will see how insertion sort completes the sorting faster than the other two, and even more so when the array is almost sorted. As you can see, insertion sort takes only 36 steps to complete the sorting, while the other sorting techniques take 39 and 44 steps. Now moving over to the almost sorted array part. Here you will see that the time difference for the sorting is even greater and insertion sort is even faster. Insertion sort is already finished. And if we have a look, insertion sort takes only 26 steps in this case, and while the other two take 56 and 45 steps. Now that we know why we should learn insertion sort, let's take a look at how exactly it works. Now we will have a look at the algorithm for insertion sort. First, we have to compare two adjacent elements. If the writer element is smaller, we proceed with the algorithm, or else we move to the next pair of adjacent elements. Here, our goal is to always have a sorted subarray before the element we pick. So if we pick the fourth element, the first three elements should be sorted. So to do that, we compare the current element with all the elements in the sorted sublist. Then we shift all the elements in the sorted sublist to the right if they're greater than the value to be sorted. After that, we insert the value in the right place. We repeat this until the array is sorted. Now we are going to take the look at the algorithm in Java. We have taken the class insertion sort, the main function and the array with its length. First, we are going to take a for loop which will run from 1 to n, iterating over all elements in the array except the first element at index 0. Then we store the current value in the variable key to be used in the rest of the program. Now we will initialize the variable j as I-1, which will help us run the inner loop. This is why we had taken the for loop from 1 instead of 0. Otherwise, while taking I-1 here, we would run into the index out of bounds exception. Now we will take the while loop. The while loop will run until either j becomes -1 or the element at j becomes greater than our key. So we will write while j is greater than 0 and array of j is greater than our key element. By doing this, we will be able to iterate over all the elements coming before the current elements, which, as mentioned before, are to be sorted as part of the subarray. Now inside the loop, we will keep shifting the element at j to its right to make space for the key element, so that when we stop this iteration, all elements are one place closer to their sorted position and we will be able to place our current key to the correct place. So to do that, we can write array of j plus 1 equal to array of j. By doing this, the writer element at j plus 1 becomes equal to the element at a of j. And then we do j minus minus to stop the loop. After ending the loop, we will simply insert the key at the correct place. We are writing j plus 1 instead of j because the loop will always end to the left of our desired position because there will be this extra j equals to j minus 1 at the end. Now we can simply print the array. Now we will run the program. So as you can see, the printed array is sorted as 1, 2, 3, 5 and 8. Now we are going to take a look at its working. Suppose we have an array 2, 8, 3, 5 and 1. Now according to the for loop, we will start at a of 1, that is 8. So in this case, the subarray is going to be 2 and 8, which is already sorted. So in this case, the while loop will become false instantly and we don't enter the loop, since the key 8 has to be smaller than the value, which in this case is 2, and the statement is false. So moving on to the next element, that is 3. Here the subarray is going to be 2, 8 and 3, which is not sorted. So we enter the while loop now. So at this point, the value of j is 1 and key is 3. Now j plus 1, that is a of 2, becomes 8. Now we swap the elements and j plus 1, that is a of 2, becomes 8, and now j becomes 1. Now since 2 is smaller than the key, the loop stops, and here we make a of 2, where 8 was previously, equal to 3. Hence sorting the subarray. After this first iteration, the array is going to look something like this. In this case, now we see that 2, 3, 8, the previous subarray is sorted. Now moving on to 5. In this case, our subarray is going to be 2, 3, 8 and 5, which is not sorted, and 5 needs to come to the place of 8. Now a of j plus 1, that is a of 3, becomes 8 and j becomes 2. Now since 3 is smaller than the key, the loop stops, and this makes a of 2 equals to 5. After this iteration, the array is going to look something like this: 2, 3, 5, 8 and 1. Now we move over to the next iteration. Now our current element is going to be 1 and the subarray is going to be the whole array. Now while entering the while loop, since 1 is smaller than 8, we shift 8 to the next place. After that, since 5 is greater than 1, we move 5 to the right place. Then 3 is greater than 1, we do the same for 3 as well as 2. After this, we see we have reached the beginning of the array and 1 will be placed there right away. Now finally, this is how the array is going to look. So this is how insertion sort works. I would like you to repeat the process for the given array 2, 3, 1, 8, 4 and do the dry run. This will make you understand insertion sort even better. Thank you for watching. I hope you liked the video. Please give your feedback so we can improve. If you have any doubt, feel free to post it on the forum.